I didn't do a countdown. Damn it. I normally do count. Well, actually, you know what? This is like less official. This is just more like let's just form a miniature study group and really like comb through some. Damn it, I'm getting audio feedback. Oops. No, so I actually should have muted my my YouTube channel because I haven't got the audio coming through. Yeah. Anyways, welcome everyone. Good morning, good afternoon, good evening, good night, wherever you are. We are going to dig into some networking fundamentals, and we'll get pretty deep. But I wanted to use the Cilium CNI and Kubernetes as a backdrop to be able to do this because there's so many different moving pieces within Kubernetes itself. There are pieces within Cilium as a CNI, and I feel like there's enough between those two systems alone that we can dig into just the networking fundamentals. Like even if we went back to just looking at a node and what it does, there's so many different directions that we can go in. Now, one of the ways that I'm actually going to record show notes, which I'll share with y'all, is through Google Docs. And I think we'll migrate to something a little bit more polished, polished in the next episode. But I wanted to start us off. So before I share, why don't we go ahead and introduce ourselves? My name is Marino Wijay. I am a Canadian. I am a father. I'm a husband. I live up in somewhere in the GTA, the Greater Toronto area. And I work in the tech space in open source. I love networking, and that's why we are here. And while I originally planned to have just Aakansha here, we have some lovely guests with us today. So Aakansha, why don't you go ahead and introduce yourself? And then we'll
Hey
pass along.
everyone, I'm Aakansha and I am working as a DevRel at Empathy Ops. And I love going to conferences, meeting new folks, and currently I'm deep diving into cloud native technologies. And I love hosting spaces as well. So feel free to join our Twitter spaces that we host every week. So yeah, that is pretty much about me. Leon, you want to go ahead?
Yeah. Hi everyone, I'm Leon. I work as a customer success engineer at Solar.io, usually into the DevOps space and the hardware space and organizing meetups and all this. So yeah, that's about me. You wanna go ahead, Tanashe?
Hi everyone, my name is Tinashe. I'm currently with AWS, working as a system engineer in the Cape Town office, South Africa. Just helping our customers run cloud native applications on AWS, mostly EKS, ECS, and all that other stuff. So yeah, I'm just here to just learn about Cilium because we've got most of our customers running EKS anyway, so they use Cilium. I think it's a CNI of choice. So I'm quite interested in knowing more about Cilium and see how everything goes from there.
Go ahead, Dan.
Cool. Hi everyone. So my name's Dan. I am a principal community advocate at iSurveillance, working on Cilium, lots of eBPF. Background is kind of a little bit all over the place, but Docker, Heptio, HPE, VMware, Equinix Metal. So I did a lot of bare metal provisioning of Kubernetes clusters and things like that. Maintain some projects that are sandbox and things like that as well. So yeah, excited for today.
I love it. We do have 55 minutes left on the stream, so I don't know. There's a lot of different directions we can go in, but I'd love to hear some additional thoughts from y'all around, what got you into networking, why you even showed up to this stream, why it matters to you, and maybe we'll start with you, Dan, and then we'll come back around to me.
That's a good question. Yeah, I mean, my background was predominantly infrastructure, so a lot of provisioning of servers and provisioning of VMware clusters and things like that. Some networking kind of comes into that, but for the best part, it was more the infrastructure side of things. And then as my career progressed, I kind of ended up being exposed more and more to networking. So building out data centers and Originally, it was largely focused on storage area networks, and then moving on to the actual physical, communications networks and things like that. So ended up doing a lot of Cisco switches and things like that. Ended up doing the CCNA, then the CCNP, and then Kubernetes kind of came along, and that was actually Docker came along, so I did a lot of Docker networking stuff, so containerized networking, and then Kubernetes came along, and then we had to relearn everything because everything kind of all changed again. And now, I mean, I'm heavily into doing a lot of eBPF networking stuff and things like that as well, and that is a bit of a game changer from my perspective at the moment. So yeah.
Fantastic. I love that. I just want to say hello to Siddhant. Welcome to the stream. Also, a hello to Nuno. Thank you so much for coming by. Thank you. And then another from Uni. Hi, Uni. Welcome. Another one from Sid. All right. Well, let's move on to Tinashe. Why did you join this stream, and why do you care about networking? And I know you mentioned that some of the folks in your space also are interested in Cilium, so you want to learn a little bit more. But why networking? What got you into this altogether?
That's a very good question. I would say number one, one thing I've learned in the cloud native space is networking is very fundamental in how everything works, right? So with networking, be it from pods, your nodes and everything, you actually need to have that fundamental knowledge of how networking works. And now with Cilium getting recently acquired by Cisco, it shows the confidence Cisco has when it comes to using eBPF in the near future. And I just had a very eBPF, and it's going to be revolutionary, like observability and all that stuff. So coming to this stream, I'm just here to learn as much as I can.
That's awesome. Love it. All right, Leon, why networking? Why are you here?
Networking is like literally my worst enemy because I never understand how it works and how things like really flow inside. And since networking is like never like something that you can always look at and be like, okay, this is happening. It's more of like you do something and you get something out of it, and then you be like, okay, this is working, right? So I always try to like get into networking stuff, but it's a slow progress out. Yeah, that's me.
Love it. What about you, Aakansha?
Well, I'm pretty new to this space, but like I've seen in Twitter spaces, people are so passionate about this domain networking, and that's what got me interested. And I want to learn with from you folks, so that's why networking for me.
Awesome. So, like I said, we are sharing or we are taking notes in a doc, and we'll try and coordinate here. Maybe Aakansha, if you want to start, I can also add some notes as we go along. But let me talk about why I got into networking, and it really starts with like something a long time ago where I was doing the desktop and desk support and sysadmin thing for a bit, probably about 2-3 years now. Way before then, I deployed and worked with wireless networks, and that wasn't really true networking. It was just literally deploy a wireless router, and then you've got wireless cards that connect in through the 802.11b protocol. It's a really slow standard, but it's like one of the earliest protocols. It's like you realize that you've got this computer up in your little room, and then the actual main connection is downstairs in the basement, and wireless is the only way to make this possible. So I did the thing, and it was interesting to see how many people in my neighborhood were interested in the same. And so they're like, hey, what would it take to get this wireless network up and running in my little house? And so, cost of hardware and my time. And that became a thing, but I didn't really understand what true networking was until I was in one of my first roles, my actual roles. I don't know what happened to Tinashe, but I hope Tinashe comes back. I was in one of my first roles, and I was like, I hit a bit of a plateau with desktop support. Like you could only do so much with operating systems, and you could only do so much imaging of servers and laptops. But what was cool was my supervisor, introduced me to this concept of the CCNA, right? I had no idea that even certifications existed at this point in time. And so the CCNA was still too deep and too complex of a certification for me to go after, but I needed to start somewhere. And so I decided to jump into the Cisco Network Academy. The Network Academy was a very guided approach to getting your CCNA and CCNP. So I went through that, and that really showed me that I loved networking. Like, I love to see packets move. I love to see that ping go through. I love to see the reconvergence of the network in spanning tree or at a higher level protocol like BGP, for example. It was just like magic to my eyes. And, you know, for a lot of other people, maybe they didn't give a shit. That's okay. For me, like, every time I saw, you know, the request timeout and then all of a sudden it starts pinging, oh my gosh, that did it for me. But I progressed through the certification ranks, and I ended up getting my CCIE back in 2015. And it was, I got it on the second try. I went for my first attempt, failed it, came back, did my second attempt. And that's why they call it the $1,600 lunch, because it's expensive to go take the lab exam, plus the flight. Like, that doesn't include the flight to get out there and the accommodation. Anyways, it showed me how much, like, how difficult, how extreme, how varying network can become, right? But it didn't stop there. Networking was evolving and evolving in different ways. Like, look, we are staring in the face of Cilium, and it is a retelling of what networking used to be, but at the same time, accommodating of the different kinds of workloads we see today. So that's why I was like, maybe Cilium might be the best tool to demonstrate how networking works. I don't know if anyone else wants to add any thoughts around Cilium. Dan, maybe you could share some thoughts around, you know, maybe the reason behind why Cilium came to be. And then
I just you're talking about, like, you know, how you first got into networking, and you're like the first like that first wireless standard was incredibly slow, like slower than like 4G networks and things like that. And I was like thinking about the first time I actually kind of really did anything networking, and I just suddenly realized, goodness gracious, I am old. Because like the first real kind of thing I remember about networking, and I don't know if anybody is even going to know what I'm talking about, but when I was at college, I had a piece of work that was late. And the networking that we had there was based upon a very old technology, which is 10-base-2, which is coaxial cable, and it has a concept of terminators. Effectively, what that means is that most networkings, you have two ends to the cable. You plug one thing into a computer or a server, and the other end into a switch or another networking device. With 10-base-T, you plug everything, all connects to the same bit of cable, with the concept of these T pieces, which effectively cable goes into one end. It's the shape of a T. One goes to the computer, and then one goes onto the next computer, and you connect with that. And at the end of the two bits of cable, you have the concept of a terminator. Now, if you take the terminator off, the entire network breaks, because that is effectively kind of seals the circuit of the network. So yeah, I basically kind of found where the terminator was in the college network, put it in my pocket, and took down the entire network for the day, so that I didn't have to hand in my homework. So sorry about that, everybody who had work to do with that day and whatnot. But yeah, I mean, it's incredible to think, like, I mean, that network as well was 10 megabits for the entire college. But you know, like, where things were to where we are today, networks, Wi-Fi networks now are, you know, there's new standards coming out. Wi-Fi 7, you know, kind of is out at the moment. Gigabit Wi-Fi networks and things like that. Wired networks, you know, 100 gigabit, 200 gigabit, you know, huge amounts of data. And yeah, I think one of the things that's kind of quite exciting and interesting now really is that the problem that we've kind of had is that networks were evolving so quickly and were so fast that you really needed dedicated hardware to do a lot of the processing side of things. So clever silicon by big manufacturers to kind of process the packets before they went to their end destination. And you know, with things like Cilium and with eBPF and you know, modern processors and things like that, we're moving away from having the requirements for that dedicated dedicated silicon. And we can really do a lot more processing now on the machine itself. So, with, as I say, with improvements to NICs, where you have all of the offloading that happens there, and I can't remember the Pacendo NICs that do all you can basically put code on the network interface itself. So stuff is happening in the machine as opposed to happening else and things like that. It's kind of cool to see that we're kind of moving away from being so tied to these expensive boxes, and we can do a lot more now on commodity hardware. That's what's exciting me at the moment.
It's very fascinating. You're bringing this up right now. Sidebar quickly, right? A couple of things that Uni brought up. Packet tracer, absolutely. When I was learning in my Cisco Academy, Packet tracer was the software tool that you could test out some miniature networks. It had its limitations, right? Like, it wasn't able to emulate. It was able to simulate. And there's a hard difference between the two, because you're not emulating hardware. You don't have access to real NICs, and you're not able to get line rate or close to it. Whereas you still can do a lot of different things in Packet tracer. Network Chuck. Yes, Network Chuck is another great YouTube channel you should check out. Tons of content. I think his channel's like well over, I don't know, 1 million subscribers at this point. I don't know. Packet tracer for the win. Yes, Leon, totally agree. I will also bring up Dynamip/GNS3, which is something that was allowing you to emulate routers and, well, mostly router setups. And I would use this to actually, code up or configure iOS devices, and actually simulate real BGP networks, which was really cool, because you could do this all on your Windows system. And it was all based on Linux anyways. Welcome, Abhishek. Thank you for joining. So a note on Wireless 7. Oh, yeah, go ahead, Dan.
Sorry, one last thing, because we're talking about the home lab side of things with GNS3 and things like that. There's the kind of more modern one that everybody's really talked about at the moment is containerlab.dev, which is
phenomenal.
Yeah, various devices all emulated in containers and things like that. And Cisco switches, Nokia routers, just everything. It's fantastic.
Yeah. So Nico, one of your coworkers, was one of the first people that wrote about Container Lab, and I stumbled upon his article, and it was brilliant because it created the perfect recipe for you to deploy your regular networks that you were so used to alongside container networks, and that really lends itself to a lot of different capabilities and use cases. Anyways, a note on the Mesh 7 or the Wireless 7 standard. Over the holidays, I was evaluating upgrading my wireless network because I actually had like AC3000 from like 2016. Like, I don't know, that's what, 8 years ago, Wi-Fi. Still good, but my throughput for wireless devices was about, I don't know, 100 megs, 200 megs anywhere in the house. And that's terrible. And when you're trying to do things like file transfers or game streams or something like that, you get choppy connections. So I tested out a few things. I was testing out the TP-Link AXE1100, which had a 10 gig port and 2 1 gig ports. But the odd thing about that setup was that you were kind of like limited. So you would feed in your WAN connection into your 10 gig port, and then you're left with like a wireless backhaul, or you could do wired backhaul, but you're limited to 1 gig wired backhaul, or you could flip it and you could use the 10 gig as your backhaul for Ethernet backhaul, and you could do a 1 gig connection. But I've got a 3 gigabit internet connection, so I'm not going to let that go to waste. So I returned that, and I picked up the TP-Link BE95 or the 3300. And it's like the Mesh 7 with the 2 10 gig NICs on both units and 2.5 gig NICs. And this thing is phenomenal. Like, honestly, my wiring in my house is a little interesting, and there are reasons for why I have it as is. And look, I don't think it too far into the future. I didn't think that the room that I'm in right now was going to be my office, but it is now. And so what I've ended up having to do is using a coupler between two networking, like it's really interesting. So I've got one of these routers here in my office, and it's got a connection into the wall. That connection goes all the way down to the basement. That connection terminates on a coupler, which connects out to the other unit, the other deco unit. And I still get like full backhaul speed, and it's phenomenal. It's beautiful. It just made me realize like I spent way too much time talking about wireless 7 for no reason. But it enables things in your home lab. Like if you're trying to do 10 gig in your home lab, it's the perfect fit. Like it's going to enable you to do like really super high fast storage. You could do like some HPC clustering if you really wanted to get fancy. Anyways, we're getting way off tangent here. Let's get back on track. Let's get back onto the whole notion of networking in Cilium. So I think it starts with the why of networking. And the why of networking really comes down to the fact that we have so many connections and so many different endpoints that need to communicate with each other that networking should be easy today. It is really easy today. And there's so many ways to make it easy, but the more easier you make it, the more of an obscure system it becomes. You have no visibility into what's actually going on, as is the case with like my mesh network. Unless I really dig into the software, I'm not really sure what's going on. I don't know if my packets are being redirected to some server that I have no idea where it is, and they're just like hiding the fact that there's a lot of things I don't know, right? But the reality is we can dig into some of this stuff. I could use Wireshark, which is a sniffing tool, to be able to determine where my traffic's going. So Dan, what is Wireshark? We've worked with this tool before. Why don't you tell us a little bit about it? And Leon too, if you want to jump in and share your experience.
Yeah. For people that haven't really had to do much sniffing of networking, Wireshark is I've actually got Wireshark open on this window, on another window, because I was.
You want to share?
Well, I mean, there's not really much to look at. I was basically pulling apart BGP packets.
Let's go.
Yeah, I'm gonna share my screen.
Let's just dive right in, and then we'll find our way out if we need to.
Yeah. So this is Wireshark. If you can see that, look at that. How exciting is this? So effectively, one of the things I've been doing is some underlying stuff around BGP. But so what we have here is on a machine where BGP was actually happening. I asked for the machine to effectively capture all of the packets that were BGP related. So effectively dump all the traffic that's going through a NIC. And all of that traffic is basically filtered for what's going to be on the port 179, which is the BGP port. And effectively what we really have here is everything that's happening in terms of the connection itself. So a lot of this is the first few, the top four here really are TCP setting up a connection. We now have a connection established. I've connected to 179. Do you acknowledge that? Are we SYND, etc., and all that jazz? And then the first thing that really happens is this open message here, which is the sixth one. This is where the actual application is doing stuff. So, I mean, for people who've never really had to look under the covers, a lot of packets fly back and forth before anything actually happens. So if this was a HTTP connection, for instance, if I was going to a web page, there's like 5 packets going back and forth before I even get any HTTP data. It's all setting up a connection and establishing all of that and this, that, and the other. And then once that connection is established, here we have basically my BGP setup speaking to another device on my network and saying, I'd like to peer with you. This is my unique identifier, and this is the autonomous system number that I'm using. And then later down the line, we send an update message, which is where I'm going to be pushing network information to the top of Rack Router. And this is where we start to inform networks about kind of what's actually happening and things like that. So, yeah, I've spent the last kind of couple of nights staring at packet dumps to do some pretty weird stuff. Yeah, this is what it looks like. And this is, as Marino said, a really good tool for understanding point-to-point communication. So, for instance, if you're trying to communicate with something or other, and the application's working but it's misbehaving, then this is where you'll want to drill into what's happening between the communication itself. It's when connections aren't establishing that things start to get a bit wacky, and that is been a bit of a problem in Kubernetes due to the amount of layers of things that are actually happening from start to finish.
Well, see, that's just it. There are so many layers in the world of containers and Kubernetes. Like it kind of blows your mind when you really think about how that all comes to be, and the different like abstractions that have to sit up top. Like you really think about it, it's like, okay, let me build a physical network, but oh, by the way, let me build a virtual network on top of that. But oh wait, let me build another virtual network on top. That's what we're doing. Yeah. So in any case, I'm actually just trying to pull up some slide here that I want to show you all because I want to demonstrate something important. There are some comments and questions coming in. Krish, welcome. Yes, Krish, you are super late. We already discussed the entirety of networking at this point, and you missed the entire show. I'm literally like opening up a new slide deck on the fly. I think I should just share my screen and you can all see what I'm doing. Damn it, come on. So, Leon, what's your experience working with Wireshark?
I would say I use it a lot when it comes to troubleshooting with customers because most of the times it's distributed debugging in a way, and the network is what we always have to look at. CubeShark is what we use, but since it's like with customers, they don't like to install stuff. So Wireshark is like what we directly use to like just inspect how traffic is going from the cluster, out of the cluster, back into the cluster. So that's how we sort of debug a lot of the network related issues, I would say. So it's pretty fun. I also had given like a small talk on CubeShark like months ago, but yeah.
Okay. Yeah, KubeShark is a very interesting tool as well. I'm definitely gonna bring that up at some point. We'll talk about it on a stream. And yeah, there's a comment here from Ayush. I don't know who Ayush is. Any thoughts on alcohol overdose? Unfortunately, this is not the stream for that, but maybe ask that on Twitter and someone might have some thoughts around it. Yes, Krish. Oh my gosh, I don't know what we're excited about, but yes, welcome to the chat. And this is the Ayush I was looking for. Welcome. All right, I've got the OSI model on screen here. The OSI model, what is it? It's the OSI. OSI stands for Open Systems Interconnect, and it's a model by which we understand the flow of networking, by which we understand how an electrical signal becomes an HTTP request. But it always starts with the electrical signals at that physical layer. So, my voice and my video coming across this feed here, the stream to you, is a bunch of ones and zeros, like a significant amount of ones and zeros that make this possible. But those ones and zeros get translated into hardware addresses. It gets translated into instructions, into direction, into data and payload, and that has to traverse a network somehow. So the OSI model is the standard by which we can understand how this data moves around, how it gets classified, where it originates from. Did I use really? I'm just looking at the comments. I can't. I'm sorry. Dan, you're gonna have to pick up from where I left off. I'm gonna pick myself up.
Yeah, no, that's fine. Yeah, it's funny as the OSI model. It's quite an old model that is, like we talked about the CCNAs and CCNPs and things like that. The OSI model is certainly something that like you get asked a lot of questions about. And we talk about Kubernetes, for instance. You'll hear people reference layer 4 and layer 7 quite a lot as well. So, is it layer 7 capable, or is it just doing layer 4 for advertising services and things like that? And without kind of understanding the OSI model, it doesn't really mean a great deal. So this is kind of why, when we say that this ingress gateway is layer 7 aware, we look at the OSI model and we're now aware that if we say it's layer 7 capable, that means it's application capable. And what we kind of mean by that is that it can speak application. So ingress controllers being the obvious one, when we say they're application aware, they can speak HTTP. They understand the application protocol of HTTP and can therefore act upon them. If things are layer 4 aware, then they're transport aware, which effectively means we can understand the concept of not only IP addresses, but ports. So we can see traffic coming in on a certain port, and layer 4 tends to refer to ports, which define the type of transport that's occurring in the IP TCP model. And that's where we interact with the networking traffic. So it's really where things sit in the stack. As I say, layer 7, we've gone beyond all of these other layers, and then we're looking at the application data that's in the networking data. Lower down, we look at, layer 2 is the frame. So that's from machine to machine. Layer 1 is whatever is sending that data, whether that's cables, whether that's radio signals, whether that's whatever. I mean, you say physical, but radio is a form of communication, which is a funny thing about the OSI model. Things have changed since it was originally created.
No, that's great, and it's pretty fantastic that you framed it that way. Ha ha ha! Such a bad joke.
I love layer 2 jokes, but also I get a lot of the layers, but who ever talks about layers 5 and 6 these days?
No one. It's the thing is, it's so abstracted away. But let's break this down. So physical is really about those devices, and I've got a switch that I could show you all. Actually, no, that's a bad idea. Where did it go? It's hiding somewhere. Anyways, layer 1 is really about like those devices, those physical devices. They could be anything. They could be. Actually, you know what? Screw this. I'm unplugging this for now, and I will deal with the ramifications after the fact. So this is a switch, right? This is a wireless switch right here. You see these ports? They're switch ports. So we plug cables in. Like I'm gonna go rip a cable out. Actually, no, I have a cable down here. Way too much chaos going on at this moment, but this is a cable, right? So I take one cable and I plug it in here, right? Where does the other end go? Where does the other end go? Does it go back in here? Do we want to put it back in here, Dan? No, right?
That's infinite internet, right?
Yeah, that could be infinite internet, but maybe not, right? We have to seed the internet somehow. But once we seeded it, then it's infinite internet. No. By doing so, by plugging this into this port, we actually potentially could create a loop. And the reason why we could potentially create a loop is because there is a mechanism on this device. It's a switch, and it's called MAC learning, right? It learns about addresses that are connected in. So if I connect a server, I've actually got this little Raspberry Pi here, which I can show you. So I've got this Raspberry Pi over here, okay? So this is my compute. This is my server. This could be, I don't know where the heck Dan left and went. Maybe he got angry at me because I decided to take a different direction, but that's okay. Dan will enter the chat again. I have complete faith in him. Now, we have this Raspberry Pi in here, and it's an endpoint. Now, I need to get network connectivity to this. It's got no power right now, but I still need network connectivity. So I could take this LAN cable, and I could go, up, and it technically should have network connectivity. But the reality is, I still have to do some things to make this possible. Okay, Siddhant, we're gonna kick you out if you don't stop your misbehavior here. No one needs to know about my bad cable management right now. Okay, so in any case, we've got a wireless device here, and we've got a Raspberry Pi, so it's got network connectivity. But the reality is, I've kernel panic. That's what happened with Dan. Dan should re-enter the chat shortly. So between these two, I've got a little network going on. My endpoint and I've got my gateway too, because my gateway also lives on this device. Now, I will run applications on this Raspberry Pi all day long, and I will use this device to get out to the internet, to get to other networks. Krish, seriously, like look at these comments. Aakansha, can you show some of these comments to some folks? Like, people need to see the kind of difficulty I have to endure when working with folks like Siddhant and Krish. And all right, so I'm gonna actually power this all on. We're gonna see this all in action. I'm just doing some stuff behind the scenes, but while I'm doing that, we're gonna see how networking actually works. I'm providing power to artifacts here, so bear with me for a second. And then Dan re-entered the chat, I think, so maybe someone can let Dan back in. All right, so while that's powering back on, it's like giving the network engineer with cables. Yes. It's very much that. All right. While my little network and Raspberry Pi are coming back online, I'm gonna add Dan back into the chat, so we should be good to go. But let's talk about this. So I just showed you a little bit of the physical layer, and the moment that connection was established, we now have achieved the data link layer as well. And the reason why that is because that Raspberry Pi that I was holding has something called a MAC address. And that's a burned-in address. That's an identifiable address locally unique to that device. And because it's locally unique to that device, that also means that no other device technically should have that. But in the world, we know that this is not a reality because there are other devices that have probably the exact same MAC address. We just hope, we have this very strong hope that these two MAC addresses don't end up on the same network because they're like different parts of the world. Chances are that this will never happen, but there's still a likelihood that it could be possible. Now, this could be a problem because in the process of the switch learning about all the hardware endpoints that are connected to it, which is known as MAC learning, we're learning about all these hardware addresses. The situation in which we learn about the same MAC address twice could indicate one of two things: that there's a loop in the network, or the fact that there are actually two endpoints with the same MAC address. So how do we direct our traffic to the right endpoint? That's a story for another day. But the loop situation is how spanning tree protocol, a protocol that infinitely learns about a MAC address, steps in to say, sorry, we're going to prevent this loop, and we're going to prevent an outage on the network. We can get super detailed about this, but we won't right now because I feel like there's way too much going on. All right, so as we climb up the layers, we also need globally identifiable addresses because we have locally identifiable addresses known as MAC addresses. We need something global. So we'll use something called IP addresses or IPv6. The reality, though, is that IP addresses are very finite, like MAC addresses. They're finite in the sense that there are only so many, and IPv4 addresses grant us about, 16 million usable addresses? Is that the case? Is that what it is, Dan? I don't know. I feel like I'm off with that number. It's been a while.
Yeah, I think it's in the region of 4, I think.
4 million? Okay. So maybe okay. But usable addresses in the public space, meaning like, okay, this will allow me to publicly speak on the internet, but there are a finite number of those addresses. And the reality is we have many, many more devices than we do have addresses.
4 billion.
We have 4 billion. Okay,
yeah.
That's the number. Sorry. 16 million seems like a subnet that I would use, but and I wouldn't want to use that subnet size, but 4 billion addresses seems a lot more reasonable. So we have probably, 1,000 times more devices than we do addresses at this point. And we can't easily assign each one of those addresses or each one of those devices a unique address. So the way we get around that is by masquerading, using an address multiple times over by hiding it, using this concept called network address translation or port address translation. We could get into the details of that, but it's an effective way to take one public IP address and share it with multiple private IP addresses. And we could also get into the subnetting conversation now, but oh my gosh, that is something we should save for another stream. Okay, so now we have addresses. We have globally identifiable addresses. But the thing is, if every endpoint has an address, and if every endpoint has multiple applications that have to share that address, how do we differentiate which application is doing what? So this is where the ports come in, right? The ports create a transport layer which help us identify which protocol stack is communicating on what port, what application is communicating, what service we need to talk to, and which service we're going to terminate on, right? So it creates a very distinct pathway, you could say. That's what the transport layer does for us. So let's take the standard TCP, HTTP communication. I'm going to go to, I don't know, Cilium.io, which is an HTTP communication, right? And in that situation, I'm connecting on port, for simplicity's sake, I'm connecting on port 80, right? We're not going to talk about 443 and HTTPS yet. We'll get to that eventually, but we're going to connect on port 80 for now. That is an indication on both ends that we're talking on HTTP, a protocol that is web related. We're going to send over web data and you're going to see it on your browser. That is distinct because it is a unique pathway. Now, we could have different forms of pathways. We could have a communication where I am SSHing into a box where I need to pass in commands. And that's another pathway because it's a distinct laneway from my host system to an endpoint where I'm going to pass in commands. Now, beyond layer 4, beyond that transport layer, we technically don't have access to session or presentation. In fact, these are the ways we codify how our application is going to communicate across the network. But most of the time when we're interacting with these applications, we're never going to actually interact with those two layers unless we're actually building it. So if I'm sitting at the code layer, I'm messing around with my sockets, I'm identifying which sockets I'm going to use, and that gets codified into the stack itself. Beyond that, the customization that I have access to is either going to be at layer 7 or at layer 4 and below. Now, once we jump up to layer 7, this is exactly what Dan's talking about. I'm seeing the application, I'm interacting with it. It's presented to me either in the form of a website, or we're looking at the stream right now. That is layer 7. That's the application layer. And at that layer, we have more defined information. We have more defined metadata. No, I haven't started sharing anything, Kunal, because I'm actually waiting for my Raspberry Pi to power on, which I think it did not power on because I don't know what happened here. Yeah. Anyways, I'll stop talking for a second so Dan can speak. And I'll pass the ball to Dan or anyone else that feels like they want to jump in and add some value to whatever the hell I just said, because I don't know if anything I said was cohesive or coherent because I was distracted.
Yeah, no, I mean, it does make perfect sense. It's, from a developer perspective, most people who are writing applications really probably don't really care too much about anything other than layer 4 upwards. So if you're writing a Go program, you're effectively going to say, I want to expose this port. So, for instance, if you did a http.listen, the only kind of bit of information you're passing to that Go function is the port that you're going to listen on. And then the application knowledge is basically everything layer 7 and above. And you, by default, will speak HTTP on that port and do whatever you need to do. And that's really where developers kind of can focus. Developers don't really want to care about IP addresses. They certainly don't want to care about MAC addresses. And I don't think any developer really should ever concern themselves with radio signals and cables and things like that. Like their focus really should be on kind of not really having to worry about those sorts of things, just writing the application themselves.
Exactly. I agree. I totally agree. I think my Raspberry Pi is booting up, and I'm going to just double check something on the back end here just to make sure that everything else that I expect. Oh, well, it would also help if I was connected to the same network. Because here's the other thing I have to do. I have to dual home my connection right now, which is highly risky at this point because there is a possibility, that I could disconnect myself. But also there might not be a possibility because, we're brilliant networkers here. Anyways, what I did was I actually dual homed myself to both my main internet connection, so that gives me a direct 1 gig wire, and then I've also got a wireless connection which is connected to my home lab. And one of the reasons I do this is because it just gives me flexibility. Anywhere in the house I am in, I can still get internet connection through my home lab, but I can also still access my home lab if I just decided to just do some static stuff. But what I'm effectively doing right now is I'm using the ping utility, which is validating through the ICMP protocol. It's another protocol, right? So many protocols today, which validates through this ICMP protocol that the other end that I am pinging is alive and it's going to provide a response. Now, for simplicity's sake, let's just assume this endpoint is truly who it says it is. Let's assume this is actually the Raspberry Pi. In the real world, there's a possibility that this endpoint could be something else other than a Raspberry Pi, right? We could be terminating at some proxy, some load balancer, something to that effect. And the reason we could be doing that is for security's sake, for high availability's sake, whatever. So we're going to SSH into this. And SSH is yet another protocol that we use to be able to remote into different systems and remotely, issue commands. I think that's the password. Okay, so I am on my Raspberry Pi right now. And if I do an ifconfig, which is a utility in the Linux operating system that effectively allows you to validate IP connectivity, or if your network stack, or what they also refer to as a TCP/IP stack, has IP address or IP connectivity, has connectivity to something. Now, you're going to see a whole bunch of different connections here, right? I've got ETH0. Oh, shit, that's terrible. Let's try this again. Let's do it correct. Okay, that's not what I expected, but maybe I should help me grep, man. Come on.
I think you should do it. I've config ETH0. You'll just get the information.
There we go. See, this is why I have Dan. All right. So I have config ETH0. I mean, basically,
technically, I have configs deprecated. I think you should be using IP, but
IP link. Yeah. Okay. I mean,
anyway, sorry, I digress.
Right. See, this is good though. This is really good. IP link 2. Is that how we do it? IP link 2. No.
I can't remember.
I think it's IP link show ETH0, something like that.
Oh, look at that. Unfortunately, it doesn't output the IP information. So unless there's another command we could use, but let's use ifconfig for now temporarily. Let's understand a few things. So when we were looking at that Raspberry Pi a few moments ago, that physical port that you saw on that Pi was tied to this interface that we're seeing here in the operating system. And ETH0 is representative of that. It has an IP address of 192.168.8.150. It has a subnet mask of 255.255.255.0. Now, what is a subnet mask? Like, why a subnet mask? Now, we will spend some time going into IP addressing and subnetting at some point, but to simplify what a subnet mask is, it's the definition of how large your network is and how many hosts are contained with it, and is also the definition of what your network address would be based off of what these bits are, right? Now, I could literally spend 20 minutes talking about this, but we only have 10 more minutes. There's also something called a broadcast address, and it's usually used when I want to send traffic to everything in my network, or in my subnet, I should say. There's something we're not seeing here, and it's called the default gateway. And I'm going to show you what that default gateway is by issuing a route. Now, the route command doesn't actually show me my default gateway. I have no idea why. Let's
You
try
can use try IPR, IP space R.
Yeah, that's a good point.
No, just R.
Yes, there we go. Do you see that default via 192.168.8.1? So that default is our default gateway outside of this network. So this right here is the network we're a part of, right? So we're anything within this network I could talk to. There is something tied to the network mask here that makes this very significant around who we can talk to. But if we're trying to talk to something outside of this network, we actually need this. We need this address. And this address is like the router. The router. It's like if I want to get access to some of Dan's network, some of Dan's friends, I will go to Dan, and Dan will tell me, no, you will not have access to my friends, or yes, you will. And this is how you can get to them. Is effectively what a router is. Yeah. If I want to figure out all the nice cafes in wherever Aakansha lives, I'll go to Aakansha and say, hey, tell me about all those cafes, because I won't know them. If I want to know about where to get the best Raspberry Pis, I'll go to Leon, because I don't know. Right? So that's effectively what a router is. You don't know something, you go to something else. And that's what we use the default gateway for. Yeah.
It's basically a catch-all. So anything that's not on his local subnet, so you can see the bottom two rules here, that traffic is basically just going to go straight out the box to wherever it needs to go. If I try and access an IP address that's outside of that subnet, so 10 dot something or other, we don't know about that. It's not on our local subnet. So it goes to the catch-all. It goes to that address. It sends traffic to that address, and hopefully whatever is sat on that IP address will know where to send the traffic next. So that could be your home router. If that was the case, then it'll go to your ISP, and your ISP will send the traffic wherever it needs to go. And that's effectively what's kind of happening here. It's the catch-all for where stuff needs to go if we don't know about it on our local network.
Marino, you're muted.
Oh, sorry. So 8.8.8.8 is not in our local network. And as such, we actually need to use our default gateway to get to our remote network. And what happens is, I don't see 8.8.8 locally in my routing table, in my host routing table. So I'm going to go to my default gateway. Do you know about 8.8.8.8? Yes, I do. Let me take you there. And so it takes you all the way there and back. And that's the beautiful thing about default gateways. Now, with about 5-ish minutes left, right? We want to take this somewhere, and we want to really dive deeper. So I don't know, Dan, if you're going to be available for the next one, but what I was also thinking is, let's take the approach of building out a miniature Kubernetes cluster with like kubeadm, kubevip, demonstrate the need for nodes, node IPs, node networking, and that's going to teach a bunch of people how networking works at a lower layer, and we can get Cilium deployed in the next go. Yeah. So once we have a cluster up and running, we can get Cilium up and running, and we'll end there for that next stream. But today, I want folks to see that networking can be really easy if you aren't, the one that's responsible for it. But if you are, like, holy shit, it can get pretty hectic.
Yeah, absolutely. I think one last thing really is, if you kind of want to understand what Marino was just talking about there, if you do a trace route .8.8.8.8, you will actually see all of the steps that are taking place, and you'll see every route that you don't have it installed. I can quickly share.
Trace path will be there. Common mistake. You just hit trace. No, just hit enter. Nah. Oh, it's does the IP have a trace node?
If in doubt, apt-get install. going to be the Net Tools package, I think, off the top of my head. Oop, you're on mute, Marino.
I did install NetTools, but I didn't install Traceroute.
There we go.
Yeah. So now, after this is done, I should be able to run a quick traceroute. But exactly what Dan is describing, because look, you don't just have one router that's available. The internet is comprised of many, 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 many networks that all have routers and gateways that interface with each other to trade network information and identify where resources live. So we just did a trace route, and while we could dig into every one of these line items are hop points to get to our destination. So in order for me to get to Google DNS, I have to hit every one of these routers. Now, this is my lab router. This is, I can't remember what this is. This is some router in between. This is strange. Oh, I know what this is. This is my mesh network, my new mesh network.
Your home network is so complicated. There's routers in there that you don't even know about, which is pretty.
I forgot about it. I just realized. Okay, so that's my mesh network, and then this is not my service mesh network. This is my wireless mesh network, just to be clear. And then this is my internet router. So it exits here, and then it hits the Bell network, goes a bunch of places throughout the Bell network, through its internet exchange. Hits some places in the US and eventually hits Google DNS. So there are hops throughout the network. What we don't see, though, is that if one of these hops disappears, we won't even know that it disappeared because there'll be an alternate path. And that's another area. Yeah, sure, I leaked my IP. At the end of the day, I could just do a refresh of my router and get a new IP. So I'm not really worried. But I'm a network engineer at the end of the day, so I'm not really worried about that too.
Quick, everyone, hop on.
Yeah, come on, hop on, hack into my network. But the idea is, though, like once you have all these details, you're able to figure out what your network truly looks like. You're able to figure out if there's a problem either in your local network or something further upstream. So that being said, like let's plan for our next stream out. Let's let me stop sharing and let's share our docs. Aakansha, do you want to share the docs? Question from Uni. Any plan for Cilium Week mock test? So Cilium Week is something that I'm doing with Peter and Alessandro, or that we did with Peter and Alessandro. So I have to just follow up with them and see what their availability is for that mock test and when we want to do it. But I think it'll probably happen sometime in February based off of the timelines. I mean, we might even be able to squeeze it in for the end of January. But I'm actually trying to think about the beta exam because I signed up for the Cilium certified beta. Dan, you signed up for that too, right? Or actually, you wrote the exam, or I think you might have.
I was involved a little bit in writing some of the questions, but
right. Okay.
There's, I think, let me see if I can find it. Bear with me a second. Cool. Sorry, Slack has updated and it's kicked me out of everything. That's helpful.
I love it. Oh, that's funny. All right. Anyways, so yes, what we're going to plan for next week is we're actually going to set up a brand new Kubernetes cluster. Right. We'll use the Kubernetes docs, and through the setup of that Kubernetes environment, we'll use like Civo Cloud, for example, as our playground because we get access to Civo Cloud credits. It's a great cloud environment to test out some of the stuff as well because it's easy to use just for our own testing purposes. It's also great for production, by the way, so go check it out. But having said that, yes, K8s is the back end of how this might work, but we'll set that all up, right? We'll bootstrap it with kubeadm. We'll see the node networking stand up, and then we'll also see how to install Cilium, and now that provides the container networking layer. And then, following streams after that, we can dig into some more network related stuff through Cilium and see how things like static routing, BGP routing, network policy, firewalling really come into play here, even load balancing, because there's a lot of different concepts that get covered in Cilium in networking that we could easily dig into and really establish a tie into every one of those OSI model layers. So we're going to do that. That's our goal. Our goal is to use Cilium to teach you how the OSI works, understand packet flows, understand how endpoints get their IP addresses, understand how policy comes into play, understand how we can optimize the network even. And Cilium can do all of this for us. So expect to see more of that next week. We'll follow up with another graphic. Aakansha, Leon, Dan, any thoughts, comments, questions, anything maybe we missed in this, chaotic, non-scheduled, unstructured stream?
Yeah, no, I think it's fantastic. I think there's a lot of tools out there. I think once we kind of go through setting up a Kubernetes cluster, do a kubeadm in it, things all stand up, and then probably decompose it a little bit, because it sets a lot of stuff up, and you don't really know what a lot of it is. You don't know what a lot of it is. Kubeproxy, what's that doing? Is it a proxy? What's its job? What's its role? Where do CNIs actually come in? There's a lot of things to actually decompose. And I think once we decompose everything, we can start to see a lot of how a lot of the things that we've discussed today, so the OSI model, where does that fit into things like services or pod IP addresses and ingress controllers and things like that, and service meshes. How do you know where to look? So, you've got kubeproxy doing a bunch of stuff. If kubeproxy's got something wrong, how do I debug that? If I can't access my pod or I can't access my service, why, so understanding the concepts of all of the Kubernetes networking, and then understanding what tools are going to be of some use to actually kind of look under the covers to work out why things aren't happening as you expect them to.
I agree. And I think what will help next week is I'll try and see if I can get access to ScalaDraw or another similar tool that we can maybe draw and visualize some of this as well as we're building. But yeah, I just want to say thank you all for joining our stream today. This is going to be how it is. We're just going to be very casual. There's no real structure. We're going to tangent off and talk about wireless mesh networking eventually again at some point. Leon, Aakansha, any final thoughts, questions?
Go ahead.
Oh, I was just saying that it was a fun space. There were a lot of terminologies, or the packet tracers and Wireshark I used to do in college. So it reminded me of those. So yeah, this is a fun stream, and I'm looking forward to the next one where we will be doing more hands-on.
Yeah, and while Dan is here for everyone's 10 base 2 questions, I'm here for everyone's ATM and frame relay questions. And just a special shout out to Guillaume. Welcome to the stream. Guillaume's one of my other beautiful friends out in the tech space and had a massive hand in building out Docker. So if y'all are interested, go check him out. All right. Well, thank you everyone again for joining our stream this morning and afternoon and evening. We will see you all again next week. And oh, by the way, there's another stream going on that Aakansha and I are doing with Mark from Tremolo on enterprise security and authentication. So check that out. It's tomorrow at 10 a.m. Eastern. Hope to see you there as well. Take care, everyone. See ya. Yeah, Krish, we'll get you the cable management. Take care.